All right, so 7.4, yeah, this one's good. I think that's good. Yeah, that's enough. 7.4, now we're talking officially today about similar triangles, but we've been talking about similar triangles for days now, haven't we? So we've talked about enlargements. Okay, you have an original diagram, and if you want to make one that's bigger, that's called an enlargement. Here's the enlargement. If you want to make one that's smaller, here's the reduction. Okay, but two shapes that are, or two figures, polygons, let's say, that are the exact same shape, so all the angles, corresponding angles are the same, but they're different sizes, those are called similar polygons, and we talked about that the other day. So let's focus on similar triangles today, because there's a lot of problems in real life, in the real world, that you can solve by using similar triangles. And sometimes finding the similar triangles, like identifying them in word problems, can be a little tricky. So that's sort of where we're going to go with this section. Okay? So 7.4 in your textbook, Pearson Math Makes Sense. It's going to be on 343 if you want to look there while we do this. All right, two triangles are similar if they have. Any ideas on what we might fill in there? What are your thoughts on what's the explanation for similar triangles or similar shapes we just talked about? They are the what? Okay, they have the same angles, okay, same corresponding angles. What's the high level description for similar polygons? Same what? Different what? What was that?
Same angles, different size.
Same angles, different size. Okay, so with the angles thing, we say shape, right? So yes, it's the angles that give that the same shape, but we can say same shape, and this is the one you will want to remember. The same shape, and I will put I'll put angles in there because I like that. That's part of your definition. I like that. Same shape, different size. Okay, so same shape, different size. Fill that in your spot there. Okay, so these two triangles are similar, and they have matching angles that are equal. So you guys were on the right track there. Matching angles. We also called them corresponding angles, which I'll put above. Corresponding are equal. So let's name a few. I'm going to say angle D on the first one is the same as what on the second one? Which one do you think? Yeah, it looks like angle A there. Angle A. Yeah, it could be an equilateral. It depends on how it looks on the screen versus on your paper versus on your notes. It could be stretched in your notes a little bit. They could be the same. We're going to make them different, though. So angle E is going to be slightly different than angle D. Which one would that correspond to? Looks like B, I think, would be a great answer there. And then, of course, angle F and angle C. And they'll be equal. Good. Corresponding sides are equal. Matching sides, so corresponding angles are equal, but matching sides are proportional. We talked about that word before. They are proportional. That means that their ratios will always be the same. The ratios of corresponding sides will always be the same. So you can write that like this. Let's start with side DE. That's this side right here. That is proportional to what? What's the corresponding side here? AB. Excellent. So that ratio has to be the exact same. That's what proportional means, the ratio of the sides. The sides aren't the same, but the ratio is going to be the same as other ratios for other corresponding sides. So let's go EF, and that corresponds with, BC. So those ratios must be the same. And finally, we're going to go DF and AC. So the ratio of the sides need to be the same. Good. If this was 2 and this was 4, right, we would have DE is 4, AB is 2. So 4 over 2 would be 2. So this large one is times 2. The scale factor would be 2 going from the right side here to the left one, right? And so that means that all of the sides you would multiply by 2 to get the other sides, right, whatever they are. Or going the other way, you would divide by 2, okay? But the ratios are the same. All right. So this is important. I'm not sure if we've talked much about this already or not, but this is the way that you identify if triangles are similar or not. So triangle ABC, and you would literally draw a little triangle there and type and write the vertices of the triangle right afterwards. So in this case here, the triangles that we just saw, ABC. So if I want to identify triangle ABC, I literally would draw a little triangle sign, ABC. And this little squiggly line right here, that little squiggly sign, that means that the shapes are similar. Okay? This means similarity. Similarity. And then triangle ABC is similar to triangle PQR because the angles are equal and because all the sides are proportional. Okay, so here's PQR and ABC here for this example, and they are similar, so that means that we can determine all sorts of missing pieces here. All right, so let's focus on the angles. Okay, so let's focus on the angles. So what would angle P be in this similar triangle?
70.
Yeah, the corresponding angle on the other triangle that's given is 70, so angle P is 70 degrees. Very good. What about angle Q?
80.
Angle Q is 80 because here's the corresponding angle. Yeah, you guys are awesome. And then of course, angle R is 30 degrees. Good. Now, do these angles all add up to 180? Yeah, 70 and 30 is 100 plus 80. Awesome. Okay. So X, is X 4? Because we've got to be the same, right? For the sides? X 4? X is 4, yeah? Oh, I tricked somebody. Oh, I tricked you. I got you. I got you. X is not 4, but the sides have to be what? What's the big fancy P word? Sides have to be proportional. Okay. So how can I find out what the scale factor is or what the proportion is, what the ratio is? How can I figure that out? Yeah?
You can do the two sides that you know that are 2, do 10 and 5.
Yes, the two sides that are corresponding, that are given, that we know about, that's where we start, and that's how we find out a ratio. Beautiful. Okay, now let's see. It doesn't really matter which one we put first. Let's do the big one first, the big one on top, because then we'll have whole numbers instead of fractions, right? So let's put the big one on top. I like that. So 10, try that again. Start with the top one is 10. So we have 10 over 5. And if you remember back from the other day, keep consistent. Always start with the same triangle part. So this one's going to be x over 4. Very good. That was a good notice. So cross multiply still works. 40 equals 5x, right? So 40 equals 5 times x divided by 5, x equals 8. That's better. X equals 8. Good. I thought I heard somebody say 2 earlier, but 8 is correct. So let's just double check again. So when you're done all this, you circle your answers or highlight your answers and you double check to see if you made any mistakes. So, 3, 4, 5 should be relating to 6, 8, and 10. Yeah, and each of those looks like times 2, right? When you go from small to big. Good. So 8 is the correct answer for x, and y is the correct answer for 3. Excellent. Any questions? All right. Yeah, so use those ratios when you can, or you can find the scale factor, but working with equations. All right. Let's keep going. Remember, when writing proportions for corresponding sides, make sure to keep the same triangle on the top of each fraction. Okay. Excellent. Oh, here's actually where... Oh, I did the work up here. I guess I left you some space to do the work down here. That's fine. That's fine. We did the work up here so we could see the triangles. Did you cram it into here like I did? Yeah, okay. Well, this is that's good too. Okay. So, let's any questions about that? Okay, let's move on to the second page. Example 2. Okay, so here's where we get into similar triangles that are maybe a little tougher to identify. Okay, so they aren't just like two triangles right beside each other. They're facing the same way, and it's really easy. This is like an example where you have like a real life situation where you have 2 points. This could be a point here, and there could be like a river or something like this, and then you have a point on the other side of the river, and so on, and you know what this point is, but you're trying to find where this is, let's say. So this would be an example where you could actually use similar triangles in a real life situation. So the corresponding angles, I do have that on the side given for you over here. So let's examine this. Angle O is here. That goes with angle P. Now, if this was a 90 degrees here, we don't know if it is, but if it was a 90 degrees, this would also be the corresponding 90 degrees. You see that? So that angle is pretty close to 90 if it's not 90, and that matches up with N. So Q goes with N. O goes with P, and M. Now M, I guess, would be this. This is M, and this is the M as well. Usually when there's more than one angle associated with a letter, they don't write the angles like this. Let me show you how you should write the angle. That angle M, that's a little misleading. I don't like that. So I'll put it down a little bit here for you. So this angle right here, and I'll make this in red, okay? Does anyone know a different way to write this angle right here? That would be a little more accurate than just saying M, because M could be this angle, this angle, this angle, or this angle. We don't really know. M1, well, okay, if you had this as 1 and this as 2, I don't know. Yeah, no, we probably wouldn't do that way. That's a good guess. But do you guys remember seeing this in any of your assignments? Okay, well, we have done this before in our assignments, I think. But you can label this angle right here by labeling the vertices that make up the angle. So you could list this as PMQ or QMP. So PMQ. That's this angle right here. Okay? And then this angle in blue over here then would be like NMO. So this blue one would be angle NMO. So the M is the middle letter, and then that's the one where the angle is, right? That's the vertex where the angle is. And M over here, middle letter, that's where the vertex is. So have you ever seen that before? Have you ever seen angles listed like that? Okay, I'm seeing some heads nod. That would be better than this over here, angle M equals angle M, because that's two different angles, but it shows like the same angle, so I don't really like that at all. So that's, yeah. I would write it like this, so let's rewrite that. Angle PMQ, not theta, Q, equals angle NMO. Okay. All right, so write the similarity statement. That's the next little piece here. And if you remember, we want to state the triangles that are similar, but it's important as well when we state it that we state the letters in the right order. So what is the right order? Well, let's name one triangle here. Let's do PMQ, triangle PMQ. We'll write our little similar sign. And how we write the second triangle is actually really important. We have to line up the angles that are the same. We have to write them in the same order. So remember, we went P, M, Q. So I have to start with O, because that matches with P. So triangle O. And then I got to go to M. And then I got to go to N. Okay, so PMQ is similar to OMN. And thus that order does actually matter. That order is important. All right, determine the missing sides. Let's see if we can rearrange this in our head. If you want to redraw the triangles, you can. I don't think you need to, but you can redraw the triangles. You'll have to take one of those triangles and like turn it around though. So it might be a little more work than it's worth, but determine the missing sides. Okay, let's find a ratio that we know. What are two corresponding sides that we know that we're given the lengths of? Yes, this 2 meters for PQ and 4 meters for ON. Very good. So I'm just going to say this. PQ is in ratio with ON, and that ratio is 2 over 4. Very good. So now given that, I can write an actual number ratio with an unknown in there. So I can now I can pick, maybe let's do X first. So 2 is on top and 4 is on the bottom. So 3 should be on top and X should be on the bottom. Okay, those are corresponding sides there. So 3 over X. Okay. So if we cross multiply, that's 2x there, that x moves. Cross multiply, that's 3 times 4, that 4 is gone. So 2x equals what? 3 times 4, 12. X equals 6. Okay? So let's see if that makes sense. 2 to 3 equals 4 to 6. Or 2 to 4 equals 3 to 6. Yeah, that sounds really good. That sounds really good. All right, let's find y. I can still use the same original ratio, or you can use the new one that you just found. Doesn't really matter. I'll use the same one. I'll go 2 over 4 equals y over what? Yep, 7. Now when you have your missing variable on top of the ratio, that's really easy. It's just one step. You just multiply both sides by 7. So this is the 7 comes up there. That's 7 times 2 divided by 4, or 14 divided by 4. That doesn't really simplify to a whole number, but I can write that as 7 over 2, or 3.5. Okay. All right. So you can use fractions or decimals. I would encourage you to, whenever possible, just write in simplest form fraction form. And the reason why I say that, again, is when you look towards the rest of high school, working with fractions is going to be really important. And I know that most grade 9s are not comfortable working with fractions, so adding, subtracting, multiplying. So the more practice you can get with fractions, the better. Okay? And if we're given units, let's remember to end our question making sure we have the proper units. So we do have meters in the question, so when we solve here, full marks go to the right answer with the correct units, okay? So keep that in mind. Any questions? Okay, we're going to do one more example for part A of this lesson, and then I'm going to let you do work on part of your homework. So let's work on example 3. Okay, example 3. So example 3 says identify the similar triangles. So here's one of those ones, and we did that activity yesterday, right, where we had questions like this, where we had shapes that were embedded into other similar shapes, right? And so there's a triangle that's a large triangle that's on the outside here. That's a large triangle here. So identify the similar triangles. This one is ACE. Let's say that. Where am I going to write that? Okay. So, here, write the similarity statement. So triangle, let's go ACE. That's the large triangle on the outside. Look at that. Is similar to this triangle that's embedded inside of it. The smaller one. Yeah. So that is similar to triangle. And let's make sure that the corresponding angles are written the same order. B, then C. Notice it's the same C. That's cool. And then D. B, C, D. All right, so that's the similarity statement. That's the similar triangles that are embedded in there. Any questions about that? All right. So let's match the corresponding angles. So we've got angle A. We said goes with what? Angle. Yeah, B. We already kind of figured this out in our similarity statement. So angle B, those are the same. Angle C goes with. Yeah, this is the case where you can say angle C and angle C because there's only one angle associated with C. You see that? Whereas if you have something like this and this is C, well, C is what? Which angle is C? It could be one of four. So this is a bit different. You can just say angle C is equal to angle C here. That's totally fine. Okay, and finally, angle ACE is corresponding to angle D. That's right. So you have this angle and this angle. And so if you do the angles first, then you just look at the order of angles and you go like this, ACE, that's triangle ACE, and triangle BCD, and triangle BCD. So that helps you write your similarity statement if you get those angles, you know, in the right order. That's another way to do it. All right. Okay, identify the missing sides. This is where it gets a little tricky, but we can do it if we use our proportion method. It's pretty easy. So what sides do we actually know from both of these? Which are given on both triangles? Okay, so side, not angle, but side. Yeah, I think I'm following you. Side AC and side BC. That is absolutely correct. Notice that we have the sides of the side of the big triangle, which actually is the sum of 4 centimeters and 5 centimeters. So AC is 9 and BC is 4. You guys see that? AC here is corresponding to BC. And AC is 9 and BC is 4. All right, so 9 over 4, that's going to be our given ratio. And we went with the big triangle first, so let's go with the big missing side of x. Okay, so that's going to be x on top. What number am I going to put on the bottom? 7. Very good, 7, the corresponding side. Okay, multiply both sides by 7, and we get rid of 7 on this side, and it pops up over here. And now x is on the top by itself, so we don't have to do any more manipulating or dividing, so we're good to go. So x equals, what's 7 times 9 is? Close, 63. You have the right numbers there. Divided by 4. So I don't think that doesn't go evenly, but can we reduce that number at all? Not really. So 63 over 4 centimeters is x. Okay. And let's do y then. So we've got our 9 over 4. And where's y? Oh, y is this side. Okay. So 9 is the big side, so equals y. So should I put y up top or on the bottom? Yeah, the y is the side for the big, yeah. So y is on the top with the 9, you see? The 9 over here and the y over here. So what's the number that goes at the bottom?
4.
And 4? Okay. Well, this is really easy. You actually don't have to do any math here. Well, you do have to do math, but you don't have to show work like we did before. Because if 9 over 4 equals some unknown number over 4, they're both over 4. So what does 9 have to be? I mean, what does y have to be? 9. Yeah. Because they're equal ratios. They're equal fractions. So if the 4s are the same, then the tops have to be the same. And that's going to be centimeters. And we should be done there. Okay, and if you, as a decimal, this is 15.75 centimeters. So there's that as well for x. Okay, how's everybody doing? Good? You think you can do some of these questions on your own now? All right, I'm going to give you the first part of the assignment. So the first part of 7.4 assignment on page 349, I would like you to do give me 1 second. So work on 4 to 7. There will be some more questions that will be coming tomorrow. But for after lesson 1, you should be able to do those ones. And then I'll give you some more examples to show you how to do some of the word problems that you'll encounter there, okay? So we're going to work on some word problems in part 2 tomorrow. But you can work on 4 to 7 for today.